We were asked to rationalize denominators before. This one should look way different. You might try a few things. Try multiplying by, I don't know, square root of 5 first. The trick when you have more than one number in the bottom with square roots in it is to multiply by something called the conjugate. Here's the conjugate in black on the right. This is 1 because you take all this stuff and divide it by itself, you'll get 1. So I'm not really changing the fraction I'm working with. I'm just going to be changing how it looks. And I'm multiplying. The reason why we do the conjugate, well, I should say this first. The conjugate is something where the middle term has its sign, or the last term, the last term's sign changed. So instead of a plus, you can see there's a minus there. And then, so here's the reason why we choose to do this conjugate thing. Let's multiply these out, and don't forget, it's helpful if you think of fraction as having a little parentheses around the front, because you have to know what those parentheses are first before you can evaluate the fraction. So when I try to multiply the top here, I'm just going to write the 2 in front. There it is. We can deal with that in just a little bit. Let's deal with multiplying the bottoms. Again, it's a parentheses, because we have to know what that is first. So let's multiply. Okay, I wrote them out down here. Whatever answer is going to go down here in the denominator. So let's watch what happens when we multiply the conjugates here. So this term has to multiply to both terms inside the parentheses. It's going to multiply to this one and to that one. So 3 squared root of 5 times 3 squared root of 5. The coefficients on the outside will multiply to make 9. And the numbers on the inside of the square root are going to multiply to make 25. Okay, so let's do it again. 3 squared root of 5 times negative 2 squared root of 3. Again, the coefficients are going to multiply to make negative 6, and then the numbers on the inside multiply to make square root of 15. So taking care of this guy, so this guy now has to multiply to everything. 2 squared root of 3 times 3 squared root of 5, number on the outside combined, they multiply to make 6. Numbers on the inside of the radical will make 15. And then again, 2 squared root of 3 times negative 2 squared root of 3, that's going to make a negative 4 square root of 9. And so the middle term here is going to cancel out. 6 squared root of 15 plus negative 6 squared root of 15 plus 6 squared root of 15 cancels right out. And over here we've got 25. That's going to make 5. So 9 times 5 would make a 45. And then we have a 9 here, so that's 3. So 4 times 3 makes 12. So we actually have 33 is our final answer for the bottom. Isn't that a lot cleaner than what we started with in this red fraction? If we multiply this bottom of the red fraction by its conjugate, which is in black here, it made it turn out to be simply 33. So that's the rationalization part. Maybe your teacher's okay with you stopping here because this is rationalized. You could distribute that too. That makes 6 squared root of 5 minus 4 square root of 3. But that doesn't seem simpler to me because it's just written a lot longer. I like to see things factored to see. So this is where I'd stop. You've gotten rid of the radical in the denominator. So that's it.